Okay, we're just going to finish this off. There's not too much else to talk about it, so it's pretty much exactly the same. This is the 555 project I've just done. And last time I did the video, it ended with it not actually working after some fluffing around. So this is like, it's a very weird way of doing this, but I had to double check there was. The main thing I think that was wrong is that I hadn't actually supplied the power to the supply voltage to this bit over here. So it was all a bit confusing because you've got like the supply lines coming from here to there, and you think, well, they're going from there to there, and therefore they should go from here. But it didn't quite work that way. I had to actually, partly because it wasn't charging the capacitor. So once I put those wires in, it pretty much worked fine. So I'll just prove it. Hopefully I haven't knocked a wire out and it still works. But you can see there, there's only one little problem, and I haven't actually got an answer yet. I was hoping to find my little oscilloscope and see what is happening in here, but those little orange lights, I'm going to turn it off. So you can see it flashes, and it flashes pretty much what it did before. I'm not going to bother changing it back to the 555, but that was pretty much the rate it was flashing at before. This is actually the output here. This is I can't remember what that's attached to, but it's attached to, from the looks of things, it's attached to, actually it is the output essentially, isn't it? So there's two outputs. But the orange lights mean something different. I'll turn it off because it seems my camera has trouble focusing with the lights going on and off, or just being on at all. But these two here are actually attached to a 4049, which is hidden over here. I think one of these is a 4049. And they were supposedly tapping into the outputs from the LM324, the comparator, being used as a voltage comparator. And so I would expect that the output to change between high and low, not to remain. You can see one of them was kind of flickering. So this one here kind of does this flickering thing, and that one seems kind of stable. But I thought they were loading things down and getting in the way, but they're not. They're like this little CMOS thing, and they're just sort of feeding off these 2 points here. So I would expect these things here to at least flash in some way, and it's sort of alternating as you go. But I haven't worked out why that doesn't happen. Maybe the 4049 I'm using, I think I actually swapped it over with a new one, is faulty or something. But it seems like it should do something different to what it's doing. But I can't find where I put my little tiny oscilloscope thing. So when I find that, we'll come back and have another quick look at this and see if I can work out why those don't flash. But other than that, the whole thing works. I think I might actually solder it up on a little board. But I thought, I might go back to this, it's actually kind of tricky to work out why it works if you don't understand why the 555 really does its thing. And this is the whole point of this thing, is for me to be able to understand exactly what's going on. Looking at it like this doesn't help if you're having to go backwards and forwards and saying, comparing it with this. So I drew this picture, which I hope is correct, upside down. And so this is basically this circuit here without the bits that I haven't actually done. So no control, no reset, but mixed in with the circuit from the book. So actually just applying this circuit here, but then filling in the details of what's going on inside of the IC. And I think that makes it a lot easier. So over here, so I've laid it out a bit differently. Over here we have 5K resistors creating a voltage divider. And then we've got our two comparators, and then we've got the threshold and trigger pins here, and they're connected. So these are like the little label things you do in circuit diagram stuff on your computer if you're doing, well, at least Fritzing does this, and I would expect everything to do. I don't think Fritzing does this in the best way, personally, and when I write my own circuit designer software, this will be done the proper way. But more on that another day in the future, far in the future. But basically what I'm saying here is that this thing here is connected to here. So these two things are connected, and these two things are connected, and I didn't really want to have to draw anything complicated because you get the point. But you can see here that in the circuit, threshold and trigger are both tied to the same point. So they're actually looking at the voltage at the top. So coming off the capacitor here. So this is the voltage. This capacitor is charging up and discharging. This is the capacitor from which is hidden over here, this capacitor here. This is the one that's charging up and discharging, and everything else is controlling that charging and discharging, and you can kind of see what happens. So this here is the 1/3 voltage level, and this here is the 2/3 voltage level. So threshold is comparing it, so this is using it when the voltage, so looking at this as a comparator. The inverting input has the actual reference voltage in this case, and so what will happen is if this voltage here is greater than the reference voltage, the output will be high, and if it's less than the reference voltage, the output will be low. So that just means that there'll be reset will get set when the voltage becomes higher. So the voltage from the capacitor, as the capacitor charges up, when it gets to here, when it gets higher than 2/3 of the voltage, then that will become high, and you'll get resetting, which actually means because what you're getting here is, so if you can imagine this is your RS latch, then there's a Q and then there's a not Q output. This is the not Q output. So actually when you reset it, this goes high, and that basically will activate the path to ground. So when you've got too high a voltage, so when it finally reaches the 2/3 voltage point on the capacitor, so when the capacitor has reached 2/3 of the supply voltage, this goes high, the output of this goes high, latches onto high, and it starts discharging the capacitor by essentially creating a path to ground. So this becomes a path to ground through the discharge output. So there. I had a strange panic attack while cycling around thinking about this, thinking, oh, this is actually just pulling down, and so maybe 555s can't pull up, because I forgot that's not the output. This is the output here. And so anyway, so that's actually pulling it down. And then you start to discharge it, and now as the voltage is going down, it's going to start, the voltage from the capacitor will start getting lower and lower and lower, and going down to this point here, and this one here is, so in this case the reference voltage is the non-inverting input, and the testing voltage is the trigger input, which is the same as the threshold one in this case. And so in this case here, it means when you go lower than that voltage, then the output will go high, and when you're higher than that voltage, the output will be low. So you can kind of see that, because this is the lower voltage and that's the higher voltage. If this voltage is higher than that one, the output is high, and this voltage is always down here. So the only way that this voltage is higher than that voltage is when this voltage gets lower than the 1/3 supply voltage level. That probably was way too bizarrely complicated and not needing to be explained, but anyway, the point is, this one here says when this voltage gets down to 1/3 the supply voltage, then the set input becomes high, and then therefore the not Q output will become low, and that will turn off the discharging. And then the capacitor will start to charge through here. So looking at this, so when it's discharging, you've also got supply voltage going in through RA, which I didn't really think about. So I have to think about that. This is the kind of thing. So I'm sure this is how the circuit actually, I got to double check. But yeah, so in this case, there's always, when you're discharging, you've still got all this, you're still using power through the, well, you've still got current flowing through the RA resistor. So you're still using you're still wasting energy by going through that resistor even when you're discharging, which makes, I guess, sense. But that means you should always have this resistor here, otherwise when you start to discharge the capacitor, there's supposed to be a straight path to ground. But you could get rid of this resistor and then it would just discharge straight away. So you might get maybe that's how you make a pulse circuit. So I'll have to look into the rest of this book and see what happens when you do variations in these. But anyway, that's the point. So when this one gets too low, this goes set, this becomes low, that turns off the path to ground. Therefore what's happening is that you are now charging it through RA and RB, and the capacitor starts to recharge again. And so you've latched it on and nothing will change until you get back up to this point. And then once you get up to this point, you'll start going back down again, and then you go back up to this point and you go back down again, and then you go up to this point and then you go back down again. And so you should be, if you were to measure the voltage at this thing, you get that nice little, not quite a triangle pattern. I'm not going to get it right because it's upside down, and I'm not using a very good pen. So I would like to get out the so it will look something like this. I don't know if it should look the other way around, but you know, charging up, charging down, charging up, charging down, charging up, charging down. And then of course the output is just going through basically a buffer which is being inverted. So this is matching up therefore when this. So when it goes low, then the output becomes high, and when you reach the high level, the output will become low, because go down low, set, low, and therefore, why have I got that actually? Is that what it does? I'm actually a bit confused as to what that means. I keep thinking it's over there. Isn't it over there? I always thought the output was the little circle was over there. So not too sure what that means. Maybe I did that wrong. All that I care about is that this is buffering the output from here and not disturbing this. So you would think. I mean, my one I must have had. I do. It's right there. It's the there is an internal resistor here. So. But anyway, I thought that was kind of interesting. I mean, I'm sure there's thousands of videos doing this, and it's in every single book. But it's fun to actually just sit down and make your own one, and just see how it works. So what I'm going to do is I might actually just solder these up, because with one 4001 and one LM324, you basically get two 555s, because this latch requires two NOR gates, and you've got two things, and you get four of those in an LM324, and you get four NOR gates, which makes two latches. So you can make a 556 out of those two ICs. So that will be fun as a side little hobby, which I might do it. So because I haven't got anything to solder at the moment, and that would be, well, I just can't be bothered getting around to doing it. That would be kind of fun to do. But the next thing I might go back to that little Sega Master System Mega Drive, Sega Mega Drive joystick tester, but this time we're going to use logic chips, and then they're going to do something even cooler with logic chips, so they make a little game with that, and all the other things that I want to do. But thanks for watching, and bye.